Hello everyone, I'm Arshdeep Singh Banga. My student ID is 2256155024. In this video, I'll be walking you through my proposed AWS cloud architecture design for a shopping website migration. This is phase 2 of my SIT 706 assignment, where I have designed a fully serverless globally distributed solution that addresses a set of specific business requirements. The five key themes you can see at the bottom of the slide, scalability, low latency, high availability, security, and disaster recovery, are exactly what this architecture is built around. Before jumping into the solution, let me quickly run through the 7 business requirements the client gave us, because every design choice I have made links back to one of these. First, rapid scaling. The company's traffic has been doubling every year, so the architecture needs to handle that growth automatically without anyone manually spinning up servers. Second, low latency and high availability. Shopping cart and session data needs to be accessible instantly, and if a user disconnects and come back, their cart should still be there. Third, the company wants a serverless and event-driven approach wherever possible to reduce the internal administration workload. Fourth, they want a more cost-efficient database. The current relational database is expensive and slow for what is actually a simple data structure. So we're looking at NoSQL alternatives. Fifth, security. Everything must be encrypted both in transit and at rest. Sixth, global performance. The company is expanding internationally, and users outside Australia have been experiencing slow response times. So we need to fix that. And finally, disaster recovery. The clients need an RPO of 15 minutes and an RTO of 1 hour, meaning if something goes wrong, they can't lose more than 15 minutes of data, and they need to be back online within the hour. Here's the overall architecture at a glance. I have designed it as a layered serverless stack. Let me walk you through it from top to bottom. At the very top, we have global users, people accessing the shopping website from anywhere in the world. Traffic first hits the edge layer, AWS WAF, the web application firewall, filters out malicious requests before they go out any further. The Amazon CloudFront, the content delivery network, serves content from the nearest edge location to the user. So someone in Europe gets content from a European server, not one in Sydney. Behind CloudFront is Amazon S3, which hosts the static front end, the HTML, CSS, and JavaScript files. No web servers needed. Behind API calls from the front end flow through Amazon API gateway, which routes them to the appropriate AWS Lambda function. Lambda handles all the backend logic, things like loading products, updating the cart, and processing checkouts. Lambda connects to two data services. Amazon DynamoDB stores cart and session data. It's a NoSQL database. And Amazon Cognito handles user authentication and session tokens. At the bottom, AWS Backup handles automated backup and multi-region replication, and supporting the whole system are AWS KMS for encryption, CloudWatch for monitoring, and CloudTrail for audit logging. Let me go a bit deeper on the 6 core services. Amazon CloudFront is a CDN. It caches content at over 450 edge locations worldwide. This is the primary solution for our global performance requirement. Instead of every request traveling to Australia, users get content from a nearby server. Amazon S3 is used for static front-end hosting. The website's HTML, CSS, JavaScript, and images are stored in S3 and served through CloudFront. This is serverless. There are no web servers to manage or pay for when traffic is low. Amazon API Gateway acts as the secure front-end door to our backend. It routes incoming HTTP requests to the right Lambda function, handles throttling, and scales automatically with traffic. AWS Lambda is the compute engine. Every backend operation, searching for products, updating the cart, processing an order, runs as a Lambda function. Functions scale from 0 to thousands of concurrent executions automatically. This is why I chose Lambda over EC2. There are no servers to manage, and we only pay when code is actually running. Amazon DynamoDB is the database. It provides single digit millisecond response times and scales automatically. It replaces the existing relational database which was identified as expensive and slow for the application's simple table structure. Finally, Amazon Cognito handles all user authentication. It manages sign up, sign in, and session tokens, including support for OAuth and multi factor authentication, without us having to build any of that from scratch. Security architecture. Security is a non negotiable requirement in this design. Let me walk through the four layers of protection. AWS Web Application Firewall sits in the front of CloudFront and blocks common web attacks, SQL injection, cross-site scripting, and other OWASP threats. You can configure custom rule sets tailored to e-commerce patterns like rate limiting checkout endpoints. AWS KMS, the key management service, handles encryption at rest. Every piece of data stored in DynamoDB and S3 is encrypted using KMS managed keys. Key rotation happens automatically, so there is no manual key management overhead. All data in transit is protected using HTTPS and TLS 1.3. CloudFront enforces HTTPS for every connection, and AWS Certificate Manager provisions and renews SSL certificates automatically, so there's no risk of an expired certificate taking the site down. And Amazon Cognito provides the authentication layer. It uses JWT tokens to manage user sessions, supports OAuth 2.0 and OpenID Connect for third-party login, and includes built-in multi-factor authentication. Importantly, session tokens are stored securely, so if a user disconnects and reconnects, their session is still valid, which directly addresses the high availability session requirement. Coming on to scalability and global performance, this slide addresses two of our biggest requirements: handling rapid growth and improving performances for international users. On the scalability side, the AWS Lambda scales concurrency automatically from 0 to thousands of simultaneous execution in seconds. There's no capacity planning, no pre-provisioned servers. DynamoDB on demand mode also scales read and write throughput automatically, and you only pay for when you use. API Gateway handles millions of API calls per second natively, and CloudFront absorbs traffic spikes at the edge. So a viral product launch wouldn't even hit the Lambda function until it had to. On the global performance scale, CloudFront has over 450 points of presence across 90 plus countries. This typically reduces latency by 50 to 80% for international users, addressing the concern about slow response times outside Australia directly. DynamoDB global tables take this further. Data is replicated across multiple AWS regions, so a user in London reads from DynamoDB replica in Europe, not Sydney. That gets us sub 10 millisecond database reads globally. For disaster recovery strategy, the client has two hard recovery requirements: a recovery point objective of 15 minutes and a recovery time objective of 1 hour. Let me explain how the architecture meets both. The RPO, maximum amount of data we can afford to lose, is met by DynamoDB global tables because data is actively replicated across regions in near real time. Even in complete regional failure, we'd lose at most a few seconds of data well within the 15-minute target. The RTO, maximum downtime allowed, is met by the serverless and managed nature of our architecture. There are no servers to reboot. If a region goes down, CloudFront's original failover automatically redirects traffic to the secondary region. Because Lambda, DynamoDB, and API Gateway are fully managed services, they recover on AWS's timeline, typically within minutes. AWS Backup provides an additional safety net. It creates centralized automated backups of DynamoDB and S3 data daily, with point-in-time recovery going back 35 days. And S3 cross-region replication ensures all static assets are duplicated to a secondary region within minutes of being updated. Coming on to service selection rationale, this slide shows how key architectural decisions and why I made them. I'll go through each one briefly. For compute, Lambda over EC2. Lambda is serverless, there are no instances to manage, it scales to 0 when idle, and billing is per millisecond of execution. For a shopping site with unpredictable bursty traffic, this is far more cost effective than paying for EC2 instances around the clock. database, DynamoDB over RDS or Aurora. The client's data structure is simple, essentially key value pairs for cart items and sessions. DynamoDB is purpose built for this. It's approximately 6 times cheaper at scale, provides millisecond latency, and includes built-in multi-region replication through global tables. RDS would give us SQL capability we don't need at a higher cost. For authentication, Cognito over building a custom JWT system. Cognito is a managed service that handles OAuth, OpenID Connect, and MFA out of the box. Building custom auth is error prone and a significant security liability. Using Cognito reduces risk and development time. CDN, CloudFront over a third-party CDN. CloudFront integrates natively with S3 API gateway and web application firewalls. There's no cross-vendor complexity. It also has a zero egress charges for content served from S3, which makes a meaningful cost difference at scale. Front-end hosting S3 over an EC2 web server. S3 static hosting is serverless, has 11 nines of durability, and costs a fraction of cent per gigabyte compared to paying for an EC2 instance that would sit mostly idle. Here's the full architecture diagram. You can see the complete flow I have described, starting with users at the top, flowing through the CDN and WAF edge layer down to the S3 front end, through API gateway and Lambda into DynamoDB and Cognito, and finally the AWS backup layer at the bottom. The solid arrows represent the primary data flow. This is the path a user request takes when they say add an item to the cart. The dashed arrow represents supporting connections, things like backup jobs or monitoring. At the bottom, you can see 4 supporting services: WAF, KMS, CloudWatch, and CloudTrail. These run in the background to keep the application secure, observable, and auditable. To wrap up, let me quickly summarize how this architecture addresses every requirement. Scalability, Lambda and DynamoDB on demand both scale automatically. The architecture can handle 10 times current traffic without any changes. Low latency, DynamoDB gives sub-millisecond database access, and CloudFront delivers content from 450 plus edge locations worldwide, addressing the international performance issued directly. For security, TLS encrypts everything in transit, KMS encrypts everything at rest. WF protects the perimeter, Cognito secures authentication, all boxes ticked. Disaster recovery, the 15-minute RPO and 1-hour RTO are met through DynamoDB global tables, AWS backup with point-in-time recovery, and S3 cross-region replication. Cost, by eliminating EC2 and RDS in favor of serverless and NoSQL, we are looking at roughly a 60% reduction in infrastructure costs. And finally, zero server administration. Every service in this architecture is either serverless or fully managed. The client's team can focus on building the application, not maintaining infrastructure. Thank you for your time.